Hello, in this lesson, we will continue to look at translations in terms of vectors. First, a small definition at the top here. A vector is a quantity that has direction and size. So it's going to look a little bit like array, but there's a distinct difference. So let's refresh our memory back to what array was algebraically, or excuse me, geometrically. If you have an initial point and you have a directional arrow that passes through another point, but it goes forever. I'm just going to use the infinity symbol. That's not really the official notation, but imagine that going infinitely far. That's what we'd call array. And if these were points A and B, we would call that ray from A to B, like that. So the difference is with a vector, when we talk about a vector, it has a specific size and direction. So just like a ray has direction, it has direction, but it has a size. It doesn't go infinitely far. So if I were to do a vector AB, I would still have an initial point A, and it would go to a point B, but it would terminate there, all right, at B. And we would put the arrow there, but the arrow is only to indicate direction, not to indicate going forever. So there's a little bit of difference. And the way we denote it is different. We would say it goes from A to B like this, but then we just do a half arrow. All right, we don't do the full arrow. That's a vector marking. Vector AB. So it has to have direction and size. So a true vector here in this situation, I'd also have to think about how big is that. So if this were 5 inches, then I would have a vector completed, direction and size. So in the translation to the right, the picture that we looked at before, you could write this or think about it in terms of a vector. So if we took a look at a different point here, if we look at how does D go to D prime as a vector, how does that point move over there? We've already talked about this in the previous video, but it goes to the right 6 spaces and down 2. So the vector notation is very short. You just use, they're brackets, but they're pointed brackets. You would say, well, the X value moves 6 to the right and the Y value moves down 2. So I'd put 6, -2 in vector notation. And that's just talking about all of the points, or that particular point in this case, moving that direction. Okay, let's also look at how you can use GeoGebra to do this. So moving over there to my drawing I originally made on GeoGebra. If you define a vector, and so on the left here in my tools, I'm going to find it down in lines. There's one of the choices is called vector. I'm going to choose that. You can, the directions say, click a starting point and end point. So you can choose any point on the screen here. I'm going to click here, and I'm going to go, let's do down 3 over 1. Okay. And look at that right there. So down 3 over 1 would be the vector that I define there. Then I can define a transformation based on that vector. So if I choose translate by vector, then my directions are select an object, then select the vector. Sorry for the background noise. So you can see that I created a new translation. It has new defining marks there as well. But the difference is now as I change or move my vector, if I were to move my vector down 1, you can see how that is linked to it. Down 1, left 1, up 1, left 1, and so on. You can expand this out. If you wanted your vector to go straight left, it would move that figure left.